Right, we're going to start section 5.2, getting into definite and indefinite integration. Definite and an indefinite integration is usually the measure of area under a curve. Getting ready for getting volume as well as we rotate things around the x or the y axis. But for right now, we're looking at finite sums and sigma notation. Right. The sigma looks like a funny E, and it has k equal 1 to some n, again referring to the number of partitions that we have on the of number sequences. And these are in whole numbers. We can have negative numbers as part of the process, but they are integers in nature, integers as nature. We have this concept here, which we know from the time that we were in Algebra 1, and that is the sum rule. That means that we can separate the sums and distribute the sigma between them. The difference rules, where we can do the minus and separate them. And these are all help aids to make finding summation easy. The multiplication rule says that if we have a constant attached to the variable, we stick the constant outside of the variable. Is it hot in here or is it me? Okay. And then we have the constant rule, which says the total number of elements is multiplied by that constant that was listed when no variable exists. All right. You need to know about formulas. This is all about formulas. One of them is the sum. Let's see here. The sum of k. And that means a list of numbers 1 through 5, 1 through 25, and so on can be calculated by the number of numbers plus n plus the 1 divided by 2. So this one is definitely one you should know. These two will always be given to you, and we're going to be using them. So make sure you write these down as reference. I have a handout. Nice to see you. Are you okay? I got your email. I am taping. Okay. So we'll be using the calculator for some of it, but I want you all to definitely understand how it works. So we're going to do an easy one in trig. So if we have this, we want to do the sum without the sigma notation, then evaluate. So what they want us to do is insert for k all the numbers between 2 and 6. So I would have sine of 2 pi plus sine of 3 pi plus sine of 4 pi plus sine of 5 pi and sine of 6 pi. Well, any pi is going to be what? Sine of pi. 0. Thank you. So the summation is 0. This just tells you the sequence of limits that we put when we talk about parameters of values, the quadrantals as well. Okay, so here we have this one. Well, what does this mean? All right. Well, in this case, we have some number. In this case, there are parts of 5, right? So this is 5 to the 0. This is 5 to the 1. This is 5 squared, 5 cubed, and 5 to the 4th. For k to be either 0, 1, 2, 3, 4, or appropriately marked to where it will become that. So it says, which of the following is in this output? Well, in this case, we start with 1, so it's 5 to the 1 minus 1, 0. 5 to the 2 minus 1 is 1. 5 to the 3 is 2. 5 to the 4 is 3. And 5 to the 5 is 4, which is what we have. So this one does give us that output. Does everybody see that? Okay, this guy is absolutely on point because that's what we have. So we know that one's true. Well, what about a 1? Well, notice it starts with a negative 1. So that first one is 5 to the 0. 5, if it's 0, it's 5 to the 1. If it's 1, it's 5 to the 2, 5 to the 3, and 5 to the 4. So all three of them worked. Does everybody see that?
Above the station.
Oh, here. Oh, that's the extent of the series. How these we substitute for K. I did not tell you. K is no fractions. Thank you. I didn't. But it only works with integers as to a series, and the series. Oh, this is arithmetic. Some of them, most of the series that we have are addition, like area, and we're changing the parameters. That's addition. Area. But this is arithmetic, and this are getting larger, even concept on even on. Be comfortable with that. Am I clearer? Okay, good. That's a good question. The K is what you, and that's going to be pivotal when we get to Riemann. All right. So what happens here? Well, we have a positive, a negative, a positive, a negative, a positive, and negative. And we acquire that from that negative 1. And we notice we have a negative 5 or a negative 1 isolated in this process. And we want to figure out which one suits it. All right. So in this case, right? Because it starts at where? 1, so this is 0. So this is what? 1. So we got the 1. So if I did 2, okay, 1 up here, then it would be a negative 5. And if I put in, let's just put in 6. Well, if I put in 6, it's 4, right? It's E, so it's positive.
That's 5. So it's minus
5. Yeah. So it'd be odd. So this is good. Is this good? Okay, because we start with a negative 2, right? Value. So it's still negative. That's a cool thing. For 1, see, and we got it as a positive. And this guy right here is a 1. So, no. For this is, that's just 1 times 1. we started with a no. Okay, good math, good math. Okay, so we knew this one worked and this one worked. All right, so how would we write this guy? So what do I have? Arithmetic. Yeah, okay, so we need a K, just a flat out K, right? So we know it's a K that's being added. And then we have our sigma, and we can start it where? 1, and it ends in 25. Arithmetic. Arithmetic. All right, well, what do you see in this guy? What do we see, guys? It's so we understand that we have a constant with an exponent, right? And the exponent is what changes, which is our what variable? K. Is that okay? All right. So now we're going to use our calculator. In our calculator, we're going to hit the math key, and then we're going to choose our summation 0. Choose 0. It's supposed to be an arrow down. And then we hit that, and then we enter, and you get what you need to do. So let's give it a shot. This is what you see. Does everybody find that on their calculator? All right, so we're going to give it a shot to see. I mean, these aren't hard or anything, but I mean, I made you buy something. Okay, so let's do the first one. These are showing the properties of k, k squared, and k cubed, which is part of what we do with Riemann. So we're going to hit the math key, and we're going to arrow down till we get to the 0. Enter, and it comes this way. Now, I'm not going to put k. You can if you want to, because that's an alpha, but I would just use x. And I enter 1, and I hit the side arrow, and it goes to the top, and then over, and then we're going to put our x. How are we doing? Everybody good? Well, we're going to hit that key again, and we're going to do the other one. And we're looking for the beauty of the mathematics, and I'm not doing the k, I'm doing the x. Sorry, I hit enter. Sorry. I'm going to put the 1, and then I'm going to put the 15, and then I'm going to put x squared. Oops, sorry. There we go. X squared, and enter. How are we doing? Okay. Is all good? Am I clear? Okay. Oops, sorry. Okay, I'm going to enter my x, and I'm going to put the 1. And then I'm going to put the 15. And then I'm going to put x up caret 3. Is everybody good with that? Now you can do it longhand and get the same response. That should help some of the math. Now this one, I think you have like 13, if I remember. All right. So here we have that concept where we have a division and we have n show up. The introduction of n is to get ready for the Riemann sum in some degree. So we could say that this was okay. We could do it in this fashion, and because we have n, we're using our rules in this case. So in this case, we have what? 2 times the 5. Have n squared, which is n times n plus 1 times 2n plus 1, right? I think divided by 6. Let me look. I can't mess you up. Yep, good. And we're going to enter our values. When it's n can only start at 1. If it's k can be negative values start to the n. But if it's an n, it's always 1. So if I have this guy here, this is going to cancel there. So I've got the 5 times 11, I think. Did y'all get 55 plus the 10? 65? Okay. You do it on the calculator?
Yeah.
Thank you. I was going to do that also, but that just spares me. I'm using the formula because we're going to be doing Riemann, and Riemann is a little bit different. So we're getting used to that formula that we started off with in the section. On this guy here, this one's flat out nasty. And we have a summation. Now notice that we do the summation on this guy and then cue that sum. Does everybody see the difference? You cube the sum. Okay. All right. And this guy is, so they kind of look the same in the sense that we've got an internal part and an external part. So here we go. Okay. So this guy right here is 56 divided by 2, right? Because that is the cubed. Did I get the wrong formula?
It's right for the first one, but the second one is K, but it's.
This is for the cube. Oh, oh, yeah, oh, because it was, squared. It was squared. Yes, it is the same.
Okay.
It is because it's squared.
The outside is.
Yeah, it looks like a cube. Yep. Now this one's going to be affected by the math. So that is going to be what, 28 squared? All right. So I'm going to do it. Now I'm going to use my calculator. But yeah, that was a good question. Now remember, when this was really groundbreaking because we didn't have the calculators that we have. You could have inserted this guy all the way through and gotten the same. But I wanted to show you this process, and this shows you that this k squared is, because the whole item is squared, is equivalent to the k to the third power. It's awesome. All right, now this is getting for Riemann, and I gave you a handout for this guy. And what we want to do on this guy is talk about what we learned in 5.1 and now apply it with Riemann. And the first 3 graphs are just graphs. We're going to plot and look to see how that area works on the summation. Notice that in our partition of the interval into 4 subintervals, then add your sketch, the rectangles for the Riemann, and then do a left-handed endpoint, a right-handed endpoint, and the midpoint. And all we're doing is sketching.
I need one of those.
Okay, so and this is easy because it's an f of x equals an x squared minus 1. And we have the closed interval of 0 to 2. And we have 4 partitions. So I'm going to put like this. So if I cut it in half, it's a 1. If I cut it in half, it's a 0.5. And if I cut it here, it's a 0.75. Or, I'm sorry, more than that. Sorry about that. 1 and 2. Oh, so sorry. This is 1.5. Sorry. So those are my partitions. And that's what I want on values so that I can graph it. So here we go. Let's look at my calculator so I don't make a mistake. The only setback is the minus 1. What did I have? X squared, right? Minus 1. So at 0, let's see, did I do it right? X squared minus 1. So at 0, we've got a negative 1. At half, we have negative 3/4. And at 1, we should have 1, or 0 rather, sorry. At 2, we'll have that 1. At 1.5, I'm going to have 1 1/4, and at 2, I've got 3. Sorry. Yep. We're squaring. Okay. So I've got what I need. -1, 3/4, 0. Oh, sorry. I plotted that on the plus. Sorry. 0, and a 1 is 1 1/4, and at 2, oh, wait, when I make a mistake, I make it big. This is 1 1/4. 2, it is 3. There you go, Alma. Okay, that's what I wanted. Okay, so I'm stopping at the 2, and it said to draw left hand 4. So it would be at this point, and our triangle would be this way. And at this point, it would be nothing, it'd be 0. And at this point, for this point here, it would be, because it's left point. Sorry about that. It's right here, it's down here. And then on this guy, it is right here. And of course, we know that that is not a good way to do that. And I gave you enough room. Mine don't have enough room to show the distinctions of the rectangles. This one is this, 0. All right. Then that's left. And on the right, I'm just doing it bigger. There you go. Okay. We have the same values, and have a -1. At the half, I had, what did I have, a quarter? No, I had -3/4. -3/4, right about there, a 0. And at 2, I had 3. Okay, so it went like this. All right, and then we're partitioning on the right end. So on this guy here, we're doing that one, because that's on the right end. On this one here, we're doing, because this is this guy. So on this one, it's that. And on this guy here, it's this one. See that we would have a better opportunity of looking at what these guys are. That one's it, that one. So that was just the midpoint is really the good one, as we know, because we did it earlier. So you get the idea on that. Let's look at the math for Riemann. Let me see, where's my Riemann word? I didn't put a Riemann word. Huh. Okay. Riemann is the consideration of what we did in 5-1, but with infinite partitions. All right, so we're using Riemann, and Riemann says that we have and I wrote that down because I didn't put it in my notes. Let me find it so that we'll follow the rule. And it's written in form where we use the same principle of a delta x, but we're dividing it into infinite number of partitions. And this is a definite interval. Okay, so we're saying we're taking the difference, what the length of what we're measuring for delta, and we're doing the b minus a. And then we're saying, okay, we'll take the first part, and he wrote it like this. Where the k is 1 and it goes to n of the function, where the first entry, that first part of that, which is usually 0, plus the k, meaning whatever the rule is for that function, times b minus a by n. Okay, now what this does is tell you what k is moving to, in that height that we need, because this is a function notation. And then we're multiplying by b minus a divided by n. Very, very unusual. So what we come up with, and this is how I'll mention it, this part right here is going to refer to our C of I, and this is, of course, our delta x, area of a rectangle. I didn't put it in my notes. I had to go back and say, oh, I forgot that. All right. So we're not using graphing, but we understand that we're going to be doing the graphing in our brain. And we're going to do some math. Here we go. Is everybody ready? Now this is crucial to do the homework. And I put that on the paper. So I don't go crazy on. All right. Okay. So here we have, it says, for the function below, find the formula of the Riemann sum obtained by dividing the interval n, the closed interval a to b in n equal subintervals, and using the right-hand endpoint for each c of k of the sum as it approaches infinity to calculate the area. All right, so here we go. So our first thing is to find our delta x. And our delta x is 1 minus 0 divided by n, 1 over n. All right, so we have our delta. And now we're going to find our c of 1, of I. In our c of I, okay, that means we're going to have 0 dropped into our formula. So this is 0 and this is 0, so it's going to be 0 plus our k. Oh, let me do this. Hold on. I don't want to do both of them together. I want to do them separate because one of them is squared and one of them is x. All right. So I'm going to do the sigma of k equals I to n, or I equals, so I should say I equals 0 to n, because the number of partitions, actually, it's 1. And we're going to put in our x plus our sigma. We're going to put in our x squared, because we're using those formulas. And this way I can tell you that if I do the first one, the C of 1 here, I'm going to have what? N times n plus 1 divided by n. 2 is for our x, correct? But we're going to multiply that by our delta x. 1 over n. Okay. Yes. I use it because I'm going to call it CI. I use CI. So I end up, well, does that bother you all? Or do you want me to use K? I changed it to I, so I left the X in there. The book uses K. All right. So, and that's our delta X, because we want that area. And now we have this guy, all right? And we're multiplying this times that. I left out a step. Hold that thought. Let me erase that. I got ahead of myself. Let me erase this. Let me do it the book way, because I'm getting you all confused. I'll do K. I better do K. Because we want C of out 1. C of 1 is going to be our K, because that's what this is, X, times the 1 over N. So that makes it K over N. That's what the book said. That's correct there. Times the 1 over N, because this is our delta X. And it said, now remember what it said. It said to take the K, multiply by that. That's what that is. And then the delta, and that's our delta. Yes. And then our C of 2 is going to be the K squared, right? And our K is K over N squared times the 1 over N. And because this is this part right here. You take the K and multiply by that and then square it. And that was, that's going to give us K squared over N squared times 1 over N. And that's right. Okay, so there I have it. So I have the two pieces. And now I'm going to structure, this guy right here. Here we go. Those are our two pieces. This one and this one. And we're going to say, when we do this part, I'm going to write it as 1 over N squared, the summation of K, of K equals 1 to N plus 1 over N cubed, summation of K equals 1 to N of K squared. There it is. So once I have this, now I'm putting it as an N, because I want an N. I'm going to do 1 over N squared, and this is N times N plus 1 divided by 2, plus the 1 over N cubed of, and that's just K squared, what's that, N times N plus 1 times 2N plus 1 divided by 6. Now let me Sure got it? Don't anybody get a headache there? Yes. Making sure. All right, because it's math. It's math. And I got to get the math going. Oops. What did I do there? 1 over n to the third n times n plus 1 times 2n plus 1 divided by 6. A lot of math on the Riemann, but I want to get it right. Okay, so we got it. All right, now we do the math. In this case, I have 1 over n squared times n squared plus n divided by 2. All right, I'm going to do this one first. Okay, so I'm going to have n squared divided by n squared, because I'm doing that division to that numerator all over 2, plus n over n squared. And that's going to give me 1/2, because we're going to have plus 1 over 2n. We're multiplying by that 1/2. And this is to infinity, so what do I have? 1/2. All right, for the first part. The second part, which is a little more complicated, we're going to do some math, some FOIL. This is n squared plus n times 2n plus 1. 2n cubed, bless you, 2n squared plus n squared plus n. So these two add up. So I'm going to have 2n cubed plus 2n squared, n squared plus n, and all over that 6. Okay, so now I'm going to do all of it, divide it by the n to the 3. And we want 1/6 of it. So this is going to give me a 2 plus a 3 over n plus 1 over n squared, all by the 6. And now we're taking the limit as n approaches infinity. Well, this is 0 and this is 0, so I get 1/3. So I have 1/2 plus the 1/3. And that gives me, and that's that area. Ta-da. So I know I scratched all over that, but it's correct. And I will keep with the K. But a K turns into N. And I thought I could do it at the beginning, but it would be confusing. But we're using that formula. Questions on the math? Now this one's a humdinger. This one takes a lot of math because it's cubed, and we've got an 8. And so our first step is to calculate delta x, which is 3 minus 0 divided by n. So that is 3 over n. Now that's the biggest issue we have. Oh, I'm out of time. Okay, I'm going to start right there on Thursday. This one takes time because there's a lot of math in this one. And you do have, I think, 2 problems of this kind. All right, guys, thank you so much. I appreciate it. We'll start there.